No, okay, so if you don't have it, if you lost it, get another one. And if you have it in your bag, get that out, and let's finish up the notes. And I think we made it to correlation. And we've got to get over all these. Yeah.
On there it says data table, but on the little packaging it doesn't have that table.
Sure. We can go over there too. Have people had a chance to answer the daily starter? So if you were to measure the average temperature for the world, how would you do so? So we're thinking about global warming. So we're trying to think about if we were trying to prove that the world was warming, how would you measure the temperature of the world? I know you're gonna hate the microphone. It's fine. Yeah, it's fine. We gotta get them moving fast moving.
I can't use the microphone.
Okay, does somebody want to take it from Nirvana?
I mean, I can answer it, I just can't use the microphone.
Okay, you gotta talk loud though.
Okay, what I would do to, let's see, what I would do to measure the temperature, the average temperature, I would do two different data tables. I would do first data table is over the week from Sunday.
You would measure it for a whole week, okay?
Yeah, I would measure the entire temperature for a whole week.
Okay.
And then I would go by like, there's the morning, afternoon, and the evening. And
Cool.
then take the average like number of when, and then compare it to another week and see what the difference is.
Oh, okay, yeah, so if we wanted to measure the temperature from week to week, this is a little tricky. Does anybody else have any thoughts on how to do it? I think you can have one, right?
Yeah, I was talking about how you find the average temperature for the world, see how it's changing.
Yeah.
And I would say something be 3 years apart or a year apart. You would take the temperature in like every different, like drastically different region.
Yeah.
The amount of regions you divide by that much, and then you do it 2 years, like a certain amount of years apart, and you see if there's a difference.
Cool. Yeah, that sounds about right. So what we would do, what NASA does, and this is one of your questions on your worksheet, which I need to pass out somewhere, is to take the data, make a bajillion different random points around the globe, and then record temperature data from all those points, and then average it. Now, something weird that they do, and we'll look at this in a second, is they don't, so what do you think the average temperature for the whole globe is? Either Celsius or Fahrenheit. I think they say it's 58 degrees. And so they could say that in 1992, when I was born, the average temperature was 58.532. But what they actually do is they found the data from 1950 or 60 to 1970 or so, and they did the average temperature for all those years, and they found an average. And then what they give you, if you're looking at the data later in the lab today, it'll just say like 2. And that 2 means that it was 2 degrees warmer that year, which I actually don't think that ever happened, because that's quite a bit warmer for average. It's in Celsius for average for the whole Earth. So you would get these little numbers. So if it was negative 0.3, what would that mean? What is it? So if it was negative 0.3 degrees for the terms of the temperature, what would that mean?
You got colder.
That means that year, that would be 1998 or something like that, was 0.3 degrees cooler than the average for that period they recorded before. So we're trying to track how the global temperature changes over time. So that's a little bit funky, and there's a NASA website that you're going to be analyzing that'll explain that. Okay, cool. So that's how they do it. There are different data sets out there that you can find. I think Great Britain has one, but we are just using the NASA data for today. If you can take one of these and pass it along. We're not going to start on this quite yet, but this is the practice data analysis for today. Okay. So for the target for today, we want to work with the class. First, we have to finish the vocabulary from the other day. Then we want to work with the class to graph and analyze a real data set, which would be temperature over time. And we want to first analyze the source of the data. So if your data is bad data, can you draw any conclusions or anything? No. So if it has bias or anything like that, it's kind of worthless. And we're going to analyze any trends in the data using a trend. We're going to install a trend line and then understand the importance of R squared, and then use vocabulary from your unit in your analysis questions. So that's the goal. We're filling out some vocabulary, but I think somebody pointed out there were some gaps in my vocabulary sheet. So we're going to make sure the first step is to fill in everything. So we will work together to fill out the vocabulary sheet. And then we will be working independently, but we'll go step by step. And actually, I said independently, but what I really want is some of this stuff is just tricky computer stuff. And some of the readings are hard, so I want people to help each other. That's the best thing for this. Okay. So, and then some misconceptions from the other day. Correlation is actually a range, and a trend line is a straight line. It's not like you're connecting the dots. But we'll go back over those things. So I think we made it, did we make it here or here?
Here.
This one?
Yes.
Okay, so let's go over this. And then I think there's some missing things here. Did somebody say something about data table was missing? Or have we not gotten there yet?
No, there's no data table.
Oh, okay, that sounds good. So why don't we talk about that too? Well, first we'll talk about causation, and then we'll talk about data tables. So, correlation, can somebody restate correlation from yesterday? Yeah.
What about the shark in the ice cream?
We got to shark and ice cream. Do you feel comfortable with correlation, or do you want me to go over it again? Not comfortable?
Oh no.
We won't, or
we don't, I don't mind.
okay, we'll go over it again. That sounds good. Oh yeah, because it was towards the end of the period. Okay. So it's a strong relationship between two factors. For the example from the textbook, it was shark bites and ice cream sales. So that's to drive home the point that just because there's a relationship between two things doesn't mean that they cause each other. So correlation is simply if you plotted them, they would form the data points, which would be like, on any particular week, you could have 13 ice cream sales, or 13 shark bites, that would be a lot, and 2,000 ice cream sales. And so you would just have, for each week, you would have your ice cream sales and your number of shark bites. And then, so this is, each data point represents 1 week's worth of ice cream and shark bites. And then what we do is we put that trend line in there. And if the points are close to the trend line, that means that there's a strong correlation. If the data points show no clear patterns, that means there's no correlation. So correlation is just actually I said it's a strong relationship, but it's a relationship between two factors. If it's a strong correlation, that means the dots are really close to the trend line. If it's weak, the computer might put a trend line on there, but it doesn't mean anything. So that's something to be able to think about. But like we said, sometimes the two things cause each other, sometimes they don't. And I think we had an example for why this doesn't. Sometimes you have an alternative thing that causes both of these things. And what was that?
Summer.
Yeah, it was the summertime. Okay. Let's move along here. So causation. So we were saying that correlation does not mean that one thing causes another, but sometimes it does. And the difference between causation is it only goes one way. I think the most, I did this one for driving your car burns gasoline. Burning gasoline doesn't drive your car, but that's kind of confusing. You could kind of argue that you could go both ways. So I think the best one here is that texting causes car crashes. So that if you're texting, you're more likely to get in a car crash, right? If you get in a car crash, are you most likely to like start texting? Well, maybe, but we're thinking it goes one way. So if we have this guy, and if we were to graph it, if you eat too much, that causes obesity. And so this is a causal relationship, and there's some facts behind it. There's some understanding behind it. There's some research behind it. Versus sharks and ice cream, there's no, you can't like research and be like, oh yeah, sharks like ice cream too, or something like that. There's no logic behind it. Here, we know that when you eat too much, you eat too many calories, those calories are stored as fat. So there's logic backing up the relationship. So that's kind of what we need. Texting, you're not watching the road, you're more likely to crash into something. Now, when we do this whole y equals mx plus b business, what goes in and what goes out? Which one is x going in or is x going out? X goes in. So and x is this one, right? And y is this one. So in this case, if we were doing texting and car crashes, or let's see here, why don't we just do overeating and obesity? So let's do, so which one was x for that one, overeating and obesity? Overeating. So we would have to do some calories eaten. And you could graph that against maybe weight. Okay, and we assume that there would be a positive or negative correlation. We haven't really gone over that. What do you think? Positive or negative? Positive. So they would both be going up. So if it was negative, one could go up and one could go down. But so negative would be this way, would be a negative line, but this is a positive correlation. And first you would just some person weighed this much and ate this many calories. Some person weighed this much and then, you'd get a bajillion different data points. And then if there was a strong correlation, you could draw a line there. Obviously, maybe you're like some kind of crazy athlete, right? So the correlation wouldn't be perfect, but it would probably be kind of strong. And we know that there's a causal relationship. And if you wanted to predict it from any point, you would have to get the slope and get, what's B stand for? Luis, are you okay? What does B stand for? The y-intercept. So yeah, you could figure out that and use that to predict things. The computer is going to give that to us today if we get to that today. Okay. The next thing we have is a data table, right? On your note sheet. And I think is this somebody want to volunteer to draw a data table? Yay. Okay, somebody can just guide me through the steps. What do I do first? If I wanted to chart overeating versus obesity, how would I do that? What's it? Do that excellent. Well, so a data table is just, you could just do this guy, right? You could make a T-chart. That's essentially a data table, right? Yeah. Okay. And then you'd have what would you put over here? Maybe we put overeating. And then over here, weight. And then you would just list all your data, right? Okay, so data tables, I think y'all were fairly familiar with those. Any questions about what a data table is? Okay, all right. Let's move on here. I think I have the menu working through. So a scatter plot, y'all were pretty good at drawing scatter plots. Any questions about scatter plots? So scatter plots, each point represents, so in this case, if this is weight versus height, what does each point represent? The relationship between height and weight for, what is each point? What's that? So that's the total graph is showing that, but what does each point represent? Yeah?
An individual person.
An individual person, yeah. So the height and weight of an individual person. And that's naturally variable, like almost all data. So a scatter plot, unless it's something, there's some things like the width of the TV versus the height of the TV. If the TV is the same ratio, the width is going to go up exactly the same as the height. And there's a couple other examples like that, where you just literally have all the data points on an exact perfect line. In the real world, most of the time there is some scatter, and how close those are to a line tells you how closely those two things are related. So, and we put a trend line in, and usually that follows the regular y equals mx plus b format. And so you can get a slope, and the computer will fit this. So the trend line is just the computer says, okay, let's come up with a line where maybe half the points are above the line and half the points are below the line. So it thinks about that. And the closeness to the line tells us the strength of the correlation. This line does not connect the dots. There were some people doing that. So this is a straight line. Now if you want to get into advanced math stuff, you can also use like the quadratic formula or different types of lines, like an exponential line. So if you're trying to model the data and come up with a line that explains everything, You're trying to come up with a mathematical formula that explains the data. Maybe it is quadratic. Maybe it's a really complicated curved line. And that's possible. And the computer will do some of that for us, but we don't have to worry about that today, thankfully. Oh, yeah. Okay. Any questions about trend lines? Okay. So the R value is a measure of how close the fit of the data points is to the line. And that value goes between 0 and 1. So a 0 is there's no relationship. So this isn't a 0, this is a 0.5, because there is still kind of a pattern here. So a 0, there would be points all over the place, and you couldn't draw a line. The data wouldn't make any sense. That's like our carbon cycle game. That data you couldn't really make sense out of, right? So that wouldn't be meaningful. And there's all kinds of times where that happens. But sometimes the two factors are related. And the correlation, if something has a strong correlation, here it's 0.95, that means that trend line, that all the points fall along the trend line pretty closely. If they start to get spread apart, that means your correlation is not as strong. Which means that in this case, the x value does a really good job of predicting the y value using that formula. In this case, there's something else going on. All right? And that's a little bit tricky to get a hold of. Okay. Any questions about this guy? Okay, we made it back to the daily starter, but I think there were some other things I need to talk about, right? I think we didn't talk about bias. Let's talk about bias. Bias, did anybody tell me what bias is?
Error in data.
Error in data, so that's a good scientific definition. Oh, I have it on the cheat sheet if you have a cheat sheet, yeah?
When a friendship or like a business like deal or something like that affects your opinion.
Yeah, if Trump was colluding with Russia or something like that, maybe there'd be some bias there. Maybe Russia had a bias in affecting the election. Now, if a scientist could have a bias, so we're dealing with global warming. So what is a bias that a company or a scientist could have related to global warming? Yeah?
If a company's benefiting from it, then they would try to prove that it didn't exist.
If a company is benefiting from what?
Global warming.
Well, they would prove it didn't exist if they were benefiting from what?
I mean, if a company, not benefiting, but it's like, so let's say that someone, like another company, bigger company than that, or even the government itself could be paying that to say, hey, that's not true, just, make it.
So a company could be paying to make it say not true. So if you were a cigarette company, would you fund researchers to tell people that smoking didn't cause cancer? Yeah, cigarette companies did that a bunch. If you were a gas and oil company, would you try to show that CO2 wasn't causing global warming? Yeah. Yes. So we have to analyze who came up with the data, what their methods are, and who funded them to think about, is there bias here or is there not? They always say, so that's the classic example of people trying to say global warming doesn't exist, is oil and gas companies benefit from us burning oil and gas and making CO2. Then the other side likes to say that, researchers like to pretend that global warming exists so they can get more research money, which is interesting. Not sure if that's true, but who knows? Yeah. Which is actually true. There is a bias for scientific researchers to prove that something happened. Interesting, right? A lot of times we collect data and nothing's happening. And that scientist probably isn't going to get more money to do research if he's not saying anything interesting is happening. He or she. Yeah. Okay. Cool. Do we feel comfortable with bias? So I'm going to ask you, when we're analyzing data in the lab, I'm going to ask you to look at the website and think about what biases they might have, or if they have bias. All right. Are we ready to start with the lab? Sure. Okay, let's get our computers out. And then, did everybody get the worksheet? I think I handed that out. Did that make it all the way to the back? So the worksheet is on paper, but the lab is on the computer. So if you go to the Classroom, there is a spreadsheet, and that spreadsheet will be what we're analyzing today. Alright, I'll pull up the data from Classroom. It's the data analysis practice. We're doing actually the practice on paper, so you're writing answers on paper, but the analysis lab is still on Google Sheets here. And we're dealing with this first tab today. Tomorrow, or actually Monday, we'll be dealing with temperature and CO2 or sea ice levels, but today we're dealing with temperature here. Oh, someone actually made the graph here, so I have to get rid of that. Okay, now hopefully make sure that when you pull this up, you don't already have your graph done, because that's the whole point. But I don't think you do. I think you got your own copies, and make sure you've got a link there. Your Chromebook? We all have to make our own graphs. That's where we're learning about how to make the graphs. Can you go grab one? Please.
Wait, what's the assignment for?
It's the practice data analysis. It should be the first one in your stream. Does it show up?
No.
Oh, I must have deleted it and then recreated it for the other class. And then all right, stand by. Sorry. It's assignment for all
The nitrogen cycle activity.
No, so I created it for last period, but I think that's one. So let's see. Climate data analysis lab, and the other one is okay, it should be there now. And then hopefully we can pull up this spreadsheet and it doesn't already have a graph on it, which would be nice. Oh man. I think I made it so you edit it because I'm going to see it today. So I think I have to redo it. Sorry. Hold by. Sorry. I'll just do the no, so I just add each student gets their own copy. Alright, you're in. That's good.
It just freaked me out.
Oh yeah, because it was editing and then everyone would be editing the same one. That would be horrible and terrible. So hopefully just that spreadsheet one works. Sorry about that. Okay, so the spreadsheet has the data on it. This is the data we're looking at today unless you like work magically far ahead. This is from GizTemp, which is from NASA. And this website, the first few questions, we're analyzing where the data came from and what it means. So you could find that at that website. So I clicked on that link. This is alternate data if we ever get there. Some people must still be on that edit. So I think I resubmitted it. Hopefully it says each student gets their own copy. Okay, in any case. Who is this? Who are these people? I gotta try to. Oh, Ethan, so you gotta close it and go back and open the new one. Sorry about that. Go back to classroom and then same with John. I got messed up. All right, so let's look at the first one. And I kind of went over this some because this is hard. What do the numbers in the first column represent? So does anyone remember from what I said before what the numbers in the first column mean? That is the temperature, and what about the temperature? How the temperature's changed. What? Yeah? Anyone want to expound on that? Yeah?
Isn't mean average?
Mean is average, yes. So that is average temperature for a year, but it's 0.99, so that doesn't really make sense, right? So what does 0.99 mean? We can click on that GizTemp link to try to explain it some. And it tells you about, I'll click on it here actually and see if I can get into it. What are temperature anomalies? So temperature anomalies indicate how much warmer or cooler it is than normal for a particular time and place. In this data, it's warmer or cooler than normal for a whole year, the particular place being the Earth. So, if we go back to this data tab, and it is in Celsius, and I should have that labeled. If we go back here, in 2016 it was 0.99. If we scroll down back in time, in 1880 it was negative 0.2. And so what we have here is this data was actually created from stuff from like the 60s and 70s, which you can see things are pretty close to zero, pretty close to average. So they created a baseline, and then before them, it was a little bit cooler. And then nowadays, the global warming is really starting up, things get significantly warmer. Yeah, okay. So that first question, were we able to answer that? So do you know what the numbers mean? No, okay. So so if we had 0.99, what do you think 0.99 means? It is 0.99 degrees Celsius. I can help you with that. The temperature. The temperature of the Earth in 16. What about the temperature of the Earth? If it's 0.99, that's not like the whole Earth was 0.99 degrees.
There was just one place.
That was the whole Earth, but the 0.99 represents the average temperature and the deviation from average. So it was 0.99 degrees above average in 2016. Then they created the average from data from the 60s and 70s. Does that make sense for people? It might not. Is that cool? You got it, Nalani?
Yeah.
Okay. So what do you say? The mean. So I want you to write that out. That it's not just the mean, but the mean represents the departure from the average temperature. So if it's a positive number, what does that mean?
It's coming from negative. I don't know.
Is what you say? Yeah. If it's positive, no. If it's a positive number, that means it was a warmer than average year. If it's negative 0.3, what does that mean? It was a colder than average year. Does that make sense? Donovan, you got it? So we're working on number 1 here.
Okay.
And we're trying to say, what do the numbers represent? Do you want me to pull did you get the data table up?
Right here.
Yeah, so it's a temperature anomaly. So if it's warmer or cooler than normal for a particular place in time. The time is the year and the place is the whole planet. Okay, so we can go back here. See, it was was it warmer in 2016 or 2015?
What?
2016, okay, that sounds good. So do you get, so 0.99 means that it was 0.99 degrees above average on Earth that year.
So it was colder?
It was 0.99 degrees warmer than normal. So if it was negative 0.99, it would be 1 degree colder than average. But it's about 1 degree warmer than average. Cool. Thanks. You got it? Yeah? Okay, what's the second question? How is this data collected? And there's, if you go to that website, there's another segment on how it's collected a little bit. And I can pull that up. That website is pretty dense. So let's see if we can click on one that says, what is, so it looks like weather stations reporting surface temperature are positioned on land. And they started in 1880 because before then they didn't have good data. I feel like this doesn't do that great of a job of explaining how they did it. So like I said, that was what I said before, is they virtually created a billion little data points and they tracked the temperature there probably every 5 minutes or something like that. And then they crunch all that data into one number for the year, even though there's probably probably millions of numbers that would go into that data for the year, right? Yeah. But then you just get 0.99 out of that. Okay. what's the next one? What organization is collecting the data? What's the organization collecting the data? NASA. Yeah, NASA's the organization. And then the second question is, do people know what NASA is? What's the, what is it? Yeah, it's it says Aeronautics and Space Administration. So do you trust their data? So that's the fourth question. Do you think this data is trustworthy? Do you think it's explained enough? I mean, it's very complicated how they calculate that. And so this is a personal thing. Do you think they have bias? And so if you think they do have bias, explain for number 4 what bias they have. If you don't, you can say, no, I think they're pretty legit. Over on the other data table, which we're planning on, or not going to get to, is the UK as HADCRUT, which is essentially the same thing. And if you notice the data is similar, but not the same, which we'll get into, but we don't need to get into right now. Okay. Does anyone have any questions about those first 4 questions? Yeah. There isn't, I don't know if there's a great answer for that. It's kind of confusing. But so that would be what I was telling you, that actually it is random points around the globe that they then average over the course of the year. So they track the temperature in 1 billion randomly selected points, probably not 1 billion, maybe 1,000 randomly selected points, and then average that math out to see if it was warmer or colder. Yeah?
Wouldn't it work better to select like points in different regions that are like more drastically changed?
The HADCRUT data, I think I might have deleted it, but actually it would give you data for the northern hemisphere and the southern hemisphere. You're thinking, yeah, so if you wanted, it depends. We're trying to see if the whole Earth warmed. If you wanted to see if the northern hemisphere warmed, you would just collect data from there. If you wanted to see if Antarctica warmed, you would collect data from there.
Like collect data from every single region, every single country. Like all
that's their goal.
Regions, yeah.
To get as much data as possible to show if the temperature really is increasing on average. Because it is actually, they did say that in second period, did we watch the polar bear, or did we watch the ice video or the freshwater video?
Freshwater.
Oh, that wasn't as exciting as the ice.
Wait, what's the ice one?
No, we have to do work. But the ice one, what did you say?
Isn't it the one where it was like super intense and like the ice was regular and like the big ice that was like 100 meters?
Oh, there was that little, no, it was when you were testing. We were watching some videos. And anyways, the Arctic one explained that the temperature is warming up faster in the Arctic than the rest of the Earth. So in this analysis, we just did the whole Earth. So we would have to have stations everywhere so that we didn't, that wasn't reflected. But if we wanted to see how much the Arctic was warming, we would just have weather stations in the Arctic. Okay, are we ready to start making charts? Okay. There are instructions. Plotting the data and adding a trend line in R squared. So if you go to the bottom of the first page, you can find those instructions. You know what? Anybody want to tell me what the first step is? I like column C, which is mean, which we figured out was temperature, right? And then what do I do? Okay. Insert and then chart. Then what type of chart? Well, how do I do that? Cool. Do people want me to take a break now? We're going to catch up? Do you need to go to the nurse or are you okay? Okay. You're fine. People will catch up.
But you can't get any video.
Wait, this is the part where I want y'all to collaborate. So look at your partner and see if they've gotten it. And if they haven't, help them. Some of y'all have gotten all the way there. Some of us haven't. We've gotten halfway through plotting the points here. I'm going to wander to make sure everyone gets to halfway through plotting the points, and then we'll continue. So let's see here. we're doing this data over here, and we click this column C. Click this C letter above so the whole thing highlights.
The data range be? Oh, that's fine.
The data range.
Yeah, I was gonna ask you about that.
I don't think we have to. Select that. We have to add an x-axis. Oh, sorry. When it says that, you click B. So x-axis is year, right? We're graphing year on the x-axis and temperature on the y-axis. We're just trying to see if the Earth is warming. So that's what we're looking for eventually. You got it? Okay. Oh, there you go. Okay, now we gotta click those, we gotta click setup. And then we gotta click the line chart and make that into a scatter chart. So we scroll down there. Okay. Scatter. And then once you do that, you've got to go add an x-axis and then select column B. And then once you do that, why don't I do that here? Yeah?
I click the x-axis and then it says, what do I do?
Okay, I will show people how to do that together.
Because it doesn't say on the instructions.
So we click to the x-axis here, and then we select the B column, and then you just click OK.
Oh, right.
And then, so now we've got year here from about, where do we start here? Fred, what year do we start? Yeah? Yeah, we start about 1880. We go up to about present, and we've got temperature. And we can see it's not like it went up the whole time. So we can start to actually look at the data. So let's make sure your partner all made it to that stage. Click on it. So let's pull up that data. And then what we gotta do is click column C, insert charts. What type of chart is it? It's a scatter, so we gotta go down to scatter. Okay. And then now we have to go over to add an x-axis. And then click column B. And then click OK. All right, then we're there. All right, we got it, cool. We got it. Now you gotta add, we gotta click B up there. Okay. Yay. All right, everybody's there. So let's add a trend. Oh, wait. So we gotta click C. Up the column C. There we go. And then insert. Y'all can help each other do this as well. Insert chart. And that'll come up in a second. And then you gotta follow these instructions over here, okay? And then come in after if you want. Sounds good. Cool. Okay, are we ready to add trend lines?
What if you already did?
What'd you say? Okay. Well, if you already did, then that's, maybe you can help other people too. So then you gotta click customize over here. Is anyone stuck where the options went away? If you get stuck where the options go away, you click on the graph and click that triple thing and do edit chart. Now we gotta go to customize, series, and scroll down to trend line at the bottom of series. And the computer randomly calculates a trend line. Here you can actually see it'll calculate different types of trend line, but we're not gonna worry about that today. And then at the bottom of that, you can click show R squared, and that shows up here. And then in terms of label, in terms of label, we can do the use equation. And so now here is your R squared equals 0.754, which is a measure of correlation. So remember, if it equals 1, that means it perfectly explains the other, which means time would perfectly explain temperature. And then if it was 0, there'd be no relationship. So we have a decent correlation, but as you can see, it's not perfect. But generally, the line more or less follows the data. There are some little funky bits, but we can talk about that later. Now, this formula is annoying. What formula did we get for the trend line? Well, why don't you help your partners to make sure you all get trend line? And then the next thing we're going to think about is the formula we got for the trend line. Yeah.
When it says the D, doesn't that usually mean a scientific notation?
Yes, so I think we move it over to the left 3, right?
I mean,
People can help
if you
me.
say so.
I think so. We can see if we can argue that. I'm pretty sure when it says E, it's being evil. E for evil, and we have to move it 3 over. So what? I'll try to write it all big and stuff. What number did we get? 7.15 e to the negative 3, right? Is that true? Okay. So I think, do people want to argue against me that I think we move it 3 over, right? 1, so it would be 0.7, 2 would be 0.07, 3 would be 0.00715. Do we think that that's true? Okay, cool. So, what does 0.00715 mean? This is the equation for a line. It's just an annoying equation for a line that doesn't have a y. So we can rewrite that as y equals 0.00715, it's annoying, times x plus negative 13.9, right? Or we can just do minus 13.9. That is the equation for your trend line. So if we wanted to, when does this period go till? 1 minute, okay. Let's finish this on Monday. Thank you, should be saved.